let f of x equals 8 over x minus 2 and g of x equals 4 over x minus 4. Identify the domain of f of g of x. All right, so what f of g of x looks like is you take f, you write it out like so, but anytime you see an x, you replace it with g. So it's going to look like this. Every time you see an x, you replace it with g minus 2. Now, this tells me right now, x minus 4 in the denominator, 4 can't have it. 4 is not going to be allowed in my domain, so that's part of my answer. Moving on. I'm not done yet because I have a fraction underneath a fraction bar, and it's just I got to combine fractions, so I'm going to do that. I'm going to multiply this guy by x minus 4 over x minus 4, distribute u, and that gives me 4 over x minus 4. By the way, 8 is still on top. I don't know why I forgot to write that out. 8 is still on top. Distribute that, you get negative 2x plus 8 over x minus 4. Now, since I distributed the negative 2, you're adding here. Now that I have the same denominator downstairs, I can combine the numerator, so 8 still lives upstairs. Okay, 4 minus 2x plus 8 is 12 minus 2x over x minus 4. Now, I'm going to quick move this 8 up here and put it over 1 so I can visualize a fraction over a fraction. Whenever you have a fraction divided by a fraction, multiply the top by the reciprocal of the bottom. So I'm going to multiply this by x minus 4 over 12 minus 2x over x minus 4 over 12 minus 2x. What that does, all of this cancels out and leaves me with 8 times x, 8 times negative 4, not that that really matters, 12 minus 2x. Now I have a brand new denominator. And according to this brand new denominator, if I set u equal to 0, add 2x, divide by 2, now x isn't allowed to equal 6 either. So my domain is everything but 4 and 6, which could be written out as negative infinity to 4, union, 4 to 6, union, 6 to infinity, which is u. Yeah, not very pleasant of a problem, but boy, was it so much fun.